First off, I want to thank Patrick and Andy for having me out here again this year. This talk is going to be threat hunting focused, so we're shifting gears a bit from like the offensive side onto the defensive side. So who's responsible here for actually detecting macOS malware in your environment? Cool, so hopefully you like this talk. And so last year, what I did at Objective IDC is actually go through how to do threat hunting for macOS and mapping that to the MITRE ATT&CK framework. So this is a bit of an extension of that, and like a cool little story about how this tool came to be. So to start off, my name is Richie Cyrus. I'm on the defensive services team at Spectre Ops. Spectre Ops is known for like a lot of offensive stuff, but yes, we have a defensive team. Prior to Spectre Ops, I was at Apple on their detection and response team. And so Apple is where I really started to deep dive into how to do threat hunting at scale on macOS systems, and then also some of the challenges that arises with that. So one thing that I want to bring up is like 3 ideas regarding macOS security before we dive into the talk. So one, the number of macOS systems in the enterprise is growing. That's a known fact. Most organizations today, once you join, you get the option sometimes of even having a Windows system or a macOS system, right? And so these macOS systems, especially in Windows-heavy environments, are domain joined, and they're in the hands of people who want to be cool, right? So your executives, your C-level staff, they're like, I need a Mac because Macs are cool. And then you have like your developers or your security team that have these Macs. And so the people who have Macs in your environment, besides the people who can just get them when they walk in, they're in the hands of folks who have the most to lose, right? If that Mac becomes compromised, not only are they naively thinking that Macs don't get malware, but on top of that, if they get infected, most detection teams aren't really focused on macOS. And so it either goes undetected or they don't know what to do with it. And so it's a safe bet that as Macs take over more of the corporate space, they're going to be targeted for more malware, right, from malware authors and attackers. So that takes me to point 2. Mac malware is alive and trending upward. This is a known fact. We no longer live in the world where Macs don't get viruses, where you have like Mac and the PC guy and they're like battling out about who gets viruses. We no longer live in those times. And so not only do we not see like we see more spam, more ad-driven malware, as was mentioned today, but then one thing that's kind of rising is that APT groups are no longer just focused on Windows. They're also focused on macOS too. So you have stuff like the Lazarus group actually creating like a macOS agent. You have APT28 creating X agent, and then you have like the WinShift group who has the Winter malware. So macOS is not now exclusively just for adware folks too. You have APT groups actually targeting macOS systems. And so not only do they create their own like agents and frameworks, they utilize existing frameworks that exist out there. So take for instance the Empire project that a lot of attackers have just like pulled off of GitHub and added them to like macros and attachments and things of that sort. So it's pretty hard to do some attribution if they're going about and just stealing things like off of the internet, like Puppy or any of these like open source kind of toolkits. And so one thing that we could count on is seeing more malware and at a higher level of sophistication. And so as Apple continues to add protections in macOS with like notarization, they continue to do stuff like enhancements to Gatekeeper. You're going to see more sophistication in macOS malware. And so the third thing is that defensive controls will eventually fail or be bypassed. So this goes back to the methodology of threat hunting, right? So just on the basis of saying, okay, no matter what Apple puts in place, no matter what a product actually gives you, you can't rely on that to save you alone. You have to have some knowledge that an adversary, given enough like time, money, energy, effort, which they have, they're going to identify what you have running in your environment, and they're either one, going to bypass it, or two, find some other mechanism to circumvent what you have in place. So if we want to do detection on macOS systems, we have to have those controls in place, like EDR products, AV, right? Because they need to exist. You don't want to not have those, right? But we can't just put all of our eggs in that basket. We have to assume breach. So There's two ways to do threat hunting in general across macOS environments, Linux, Windows, right? And so it falls under compromise assessments, which is typically done by external entities, or you have kind of like internal hunts where it's more continuous and you have a team, IR team, or security operations team, and they're continually looking for threats based on the data that they collect in their environment. So both of these approaches have one major requirement that most analysts, I would think, don't think about, and that's data, right? So you think about, okay, well, what data does my product provide? And let's go one step higher than that. Not only what data does that product provide, but how does that product provide that data? And so historically, we have vendors that provide a lot of macOS data for hunting purposes. And so all of these vendors provide awesome data that is like prime for hunting in most corporate environments. And so all these solutions are more than enough to do what you need to do. However, a lot of these solutions might not be for everyone. One, because for better or worse, these solutions are like agent-based. And so you, one, need to get it deployed across your environment. And two, once you get it deployed across your environment, they have to be configured the right way to get the data that you want. And they have to be managed over time, right? You can't have say for instance, a Carbon Black agent from like 2008, in 2019, right? It just probably like crash your system if you didn't do those updates. And so the deployment and maintenance of the agents, like I said, has to be managed by at least one member of your team. And so for some, especially the cost of these, like some of these, like, OS query is like free, but you have to manage that. And someone has to actually understand how OS query works, or you have to have like the big bucks to, well, not a considerable amount of change as an organization to purchase some of these EDR products. And so in my case, what if you're a consultant, conducting a breach assessment? And for me, this is at least once a year where I come in and I need to collect data, right? I need to do threat hunting. However, the client is like, you cannot install any agents on any of these boxes, but you have to grab this data. It's like, great, how would you like me to do that? And so internally, what might happen is if you don't have the staff to manage an agent, you might be looking for an alternative approach, right? Especially if you're maybe like a startup or someone that doesn't have like a big IT staff and your IT staff is like 1 or 2 people. And then also the flip side of that is like if you're a big corporation or a big organization and you have the money to at least purchase one of these products or a similar EDR product, one thing that you might have is this real-time data such that, let's say you open calculator on a system. In a few seconds in your SIM solution, you'll be able to get, see that, hey, like Richie opened calculator on this system and at what time, right? But maybe you want alternative data besides that real-time data, right? So if you just have an EDR product that gives you real-time data, how can you identify all launch agents on a system? You're going to have a hard time doing that unless all of those launch agent binaries actually executed on that system at some reasonable amount of time, and you're able to dig into that, right? So you might want to have that point-in-time data. So how do you supplement this real-time data without having an agent? So this is something that I set out to find a solution to, right? It's kind of like I was in the middle of a compromise assessment, and I was kind of tasked to get some additional data. One, because the initial vendor that we worked with to grab some data, we gave them requirements, and it turned out less than desirable. And then the second time, we actually used OSX Collector, created by the Yelp team, but that's not necessarily designed for hunting at scale. It's designed for if a single host might be compromised and you want to get additional data on top of that. And so the output from OSX Collector was like the gzip file, and then you have to extract the gzip, and then you actually have to get the JSON file you need to ingest into your SIM. For me, I'm lazy. That's way too many steps. So in order to collect data without an agent, I needed to leverage something that already exists on macOS endpoints out of the box. So if you go to Apple Store, I wanted something that can run as soon as you take that wrapper off, no other applications on your system. So Python is perfect for that. I also wanted the output from that data to be ingested by basically every SIM solution ever. And so JSON is perfect for that. And so of that data, I wanted the data to be able to be enriched by third-party entities. And so let's say that you have the hash for a binary associated with a launch daemon, right? If you just had the name, that might not be enough, right? Because it might be similarly named to something on the macOS system already. But let's say that you have this hash. Now you can take that hash and query virus total to do some quick triage. And so this tool was released about a month ago at B/Charm in Baltimore, but here's my tool for fixing that solution. It's a macOS tool. It's Python based, so it's using Python 2.7 because that's what Mac ships with out of the box. And so it's a point-in-time collection tool. I want to caveat that. So basically, when you run this tool, the data that you get back will be the data that's collected at that given point in time. Anything that happened before and anything that happened after is like, okay, it happened, right? And that's hopefully in a corporate environment why you have that real-time data to be able to get that context around that point-in-time collection. So you might be wondering, okay, like, what does this thing actually do? We'll get into that. But to start, these are some of the modules that Venator actually collects. And so why these modules per se? Well, I feel like these modules give you the best chance as an analyst to find malicious activity based on current Mac malware today. And so all the Mac malware that was talked about today, they probably leverage one of these types of techniques, almost guaranteed. Like, I don't know the percentages on this, but I mean, us as no, probably like 80 to 85% of Mac malware, launch agent, launch daemon, all right, pack it up, go home, let's get there, right? Like I said, when you're doing point-in-time collection, you have to focus on artifacts that are representative of persistence, right? Because if you try to do real-time collection when in point in time, you're going to miss a bunch of stuff. So the assumption that we're making here when we do point-in-time collection is that the attacker or some adversary has already achieved persistence on the system, and so they're using this tool to attempt to detect them. And so when Venator is run, it's just a Python file. When it's run, all these modules are executed, and then it results in a single file that looks like this. And so you have this one single JSON file, and now what you're able to do with this JSON file is directly ship it into a SIM solution to do additional analysis. So I want to walk you through what this looks like from soup to nuts. And so I'm leveraging a tool written by my colleague, Roberto Rodriguez, called Help. So it's the hunting elk. And so it's a Kapana stack with a bunch of other threat hunting elements to it that you can use. And so to give you background on this, as we go through this right now, I have FileBeat, right? And FileBeat is actually going to be configured, as we see in the configuration pretty soon. FileBeat is going to be configured to say, okay, anything in the temporary directory that is a .json file, take that .json file and ship it to my Elasticsearch and eventually Kibana instance. So as you can see here in the configuration, we have basically anything that's in temp that's a .json file is going to be shipped off for analysis. So here, we're going to run Venator for the first time. And we realize that we have to be root in order to run this. This is only because some of the artifacts that are being parsed you have to be root to be able to parse those artifacts. And so here, there's a help for this. And so we see that we can specify the directory that we want to put in there. And so because we already know that this is being mapped to the temporary directory and we're going to get an output JSON file, we're going to do the temporary of the directory of temp. So Venator is going to run through, it's going to tell you all the things that it's collecting at a given point in time. And so it's pretty quick based on how much you have on your system. And it'll give you at the end basically how long it took and how many records. And it'll also tell you the location of where that JSON file is, just in case you weren't the one responsible for actually getting this up and running. And so what we'll see now is that this JSON file is written to the temp directory, and it's already being written to Kibana. It's going through that pipeline, that data pipeline. And so here we see that we get a lot of data back. We get all of those records back corresponding to the modules. And so one of the ways that adversaries like to basically do key login type activity on macOS systems is to register an event tap, right? And so one of the modules in here is to actually detect event taps on your system. So we go to the module here, click on event taps. And with that, we see that we have 7 event tap events corresponding to this single host that we just collected data from. Now with this, we're going to do what we call long tail analysis, such that you want to see all the unique event taps throughout their environment. So we're going to get a unique count of every event tap. So here we have 7 here. You'll soon see that we'll have some duplicates. So all these fields are associated with event taps. So we can get the tapping process name. So this is the process name of the thing that's actually doing the tapping, right? So this would be, if it's malicious, the malicious process associated with the tapping event. So here we see that we have something called blue blood. Everything else is in system or user SBIN. So it's a little suspicious, but we don't know about it yet. And so here, what we're going to do is actually look at the tapped process ID. So what process what's the ID of the process that is going to actually tap? And so here we see a result of 0 for all of these. This is actually going back to understanding your data. This 0 doesn't actually represent a single process. The 0 actually represents that all processes on the system are being tapped at this current point in time. So we see here that, hey, like this blue blood thing is actually tapping all the processes across my macOS system. So that's something as an incident responder, as a threat hunter, we want to dig into deeper. So that's event tap module. Now this is going to go into like a day in the life of Venator, like how I would actually use it on a compromise assessment. And these examples are extremely contrived, but once you get the data through Venator, you can actually build some interesting relationships on it. All right, so we've done our collection already from a couple of hosts. We have 701 events. And so the first thing that we're going to look for are launch agents, because that should be an easy win. And so with the module launch agent, you see the type of data that we pull back. You can pull back things like the host name, the hash, the executable associated with the launch agent, the raw data, the program associated with it. And so understanding the data and knowing the types of fields that we have here, we could do, again, long tail analysis via Kibana to extract out some of this data and do our hunt. And so here we have 24 events for launch agents. And for this field, what we're actually going to do is look at all the unique labels associated with the launch agents on our system. And so here, typically launch agent labels start with like com.something, com.apple, com.whatever the product is. Here we have like this media managers thing. It looks kind of weird. So let's get some additional information. So another thing that we can add on top of that is basically what is going to run whenever this is called, whenever the launch agent actually is going to launch, right? And so here we see that Java is actually kicking off a jar file as opposed to something else. So just doing a search on media managers, we can see that, hey, like Objective-C says, this is malware. I trust Patrick. It's probably something I want to take a deeper look at.
It's risky.
And so now we're going to go into login items. And so with the module login items, you could then take a look to see what fields that we have available to us at first. And in the GitHub, I have all the fields kind of parsed out what you actually get with each thing. And so here we see that we have signature information, we have the application hash. So let's go through that same exercise using login items. And so here you'll see that we'll pull back some interesting login items. So we have the application, we list 100 events. And so here we see that we have a few things that look like applications, and then you have this final presentation.app. Why would an app be called final presentation? And why is it not in the application folder? And it's a login item. That looks weird. So let's actually grab the hash associated with this login item. So we have the hash, and now we could take this hash and say, hey, virus total, what do you think about this application final presentation? So go over virus total, put that hash in, and we see that probably something that we want to get off the systems and kind of do a hunt across the enterprise to see, okay, how many of these things actually exist outside of this one system that is infected. And so the last thing that hasn't been talked about as much from the macOS side, but actually browsers and things, more specifically browser extensions. So specifically in Chrome, I have modules for Chrome, Firefox, and Safari, so that you can pull back the extensions and identify malicious extensions. So we're going to do that same exercise for Chrome extensions. And so here we see that we have the extension name, the extension update URL, the host that it was on. And so we're going to do the same exercise for the Chrome extensions. All right. So one of the things that we want to pull back is the actual extension name. All right, so we pulled back all the extension names. Nothing looks too weird. It's like YouTube downloader could be weird. Maybe flash control. We'll take a deeper dive to kind of dwindle these down. Let's dig a little deeper and actually look at the update URL. So if the update URL actually associated with a Chrome App Store extension, let's say that this extension was in the actual Chrome App Store, you'll see this like Google URL. Anything outside of that App Store is actually not from the Chrome App Store. And so we see that we have a pretty interesting update URL for YouTube downloader. And what this actually represents is that anytime that this extension is going to be updated, it's going to call out to this URL and basically pull down anything that it wants to. And so the developer at any point in time can change this update URL. If it's in the Chrome App Store, it's kind of protected from that. You'll see this Chrome update URL. The update for the extension is going to go through the Chrome App Store as opposed to this random Joe Blow, this is totally not malware or totally not YouTube downloader, that XML code. So that's a little bit about how I would use Venator day to day. So future updates, one of the things that I wanted to add to this is actually have support for sending JSON files to an S3 bucket such that today, when you execute Venator, what happens is that Venator drops this JSON file to disk, and then you have to have some kind of log ingester actually monitoring for that and sending it to Kibana or Splunk or something of that sort. Me, as a consultant doing breach assessments, it would be ideal for me to actually drop that to disk and then actually ship that off to an S3 bucket. After I ship it off to an S3 bucket, confirm that, and actually remove that JSON file from the system, right? And so from the S3 bucket, I could then send it to the SIM solution on my end. And then also additional modules like downloaded files, which would be interesting, concepts of like bash RC, files and temp, and basically anything that you want in there. If there's something that I missed, you could just do a pull request on GitHub and I'll gladly add it in there. And so that's it for me. You could find me on Twitter at RRCyrus. And quickly, I'll show you where Venator is located on GitHub. So let me change the display here. So if you literally go and get in Google and type Venator GitHub, it's the first one that pops up. Venator is Latin for hunter. I couldn't come up with a cool name, so that's it. And here you get some additional details about Venator, the corresponding blog posts as to why I went this route and some of the defensive considerations around Venator, and then some instructions about like how to run it and the type of data that you get back. So here, I actually go through and name out all those fields that you get when those modules are run, such that if you wanted to build those queries, you at least have the beginnings of a data model to start to map this data back to for detection purposes. And so, like I mentioned, it's just a single Venator.py. Run that, and you're good to go. So, at this point in time, I'll take some questions, and if not, then thank you for your time.
Hi, thanks for the presentation. This is Dimitris from Digital Guardian. So you showed us two manual actions. One where you found an interesting house and then you went to VirusTotal. The other one was when you identified this interesting update URL that was in Google. So have you automated this because you could throw all passes to VirusTotal, or you could actually automatically find these update URLs that are not Google? So have you automated this task?
So it's not in the tool itself. One of the things for threat hunting that, like, I believe in and most Suspected Ops believes in is that you want the raw data, and then once you get the raw data, kind of do the enrichments on your end. Stuff like VirusTotal additions to it, like enhancements, that'd probably be something that I do on like the back end, but that requires like a specific like VirusTotal account that you'll be able to query a lot of those hashes in a quick fashion, as opposed to waiting for like that. I think it's only like four requests in like a minute or something like that. So at scale, you probably want something more robust. So it's like I could build it in here, but it would then take away from the threat hunting aspect of it. It would be kind of almost like automated analysis. So.
Really good presentation, thank you. Have you? I noticed that you're using Pi, Objective-C, or whatever the library's called. But have you had a look at sort of how limited you'll be by just having to use like just basic, like Python without any modules? Like, have you come up against anything where you've wanted to do something and not been able to because you can't import external modules?
Oh yeah. Like the reason, so it's been that's one of the things with this project. So one of the things that I wanted to was a hard thing for me was to actually not have any anything that you have any external dependencies, right? And so everything had to be either native Python or macOS specific Python. If you try to do like Python 3 or download Python from the internet, it won't be the same as the macOS Python that is shipped, right? Because it has additional stuff in there. And so some of these like functions, API calls that were used with the Pi Objective-C bridge was extremely difficult for me because one, it's not documented, and two, for the Python and some of those Objective-C, Pi Objective-C kind of mechanisms aren't documented at all. So it's literally like trial and error from December of last year all the way through, I would say, to March of this year. So if it was like login items specifically, Patrick had a blog post about how to parse login items because the format changed. And so if it wasn't for that, I don't know if I would have gotten close. Sarah Edwards, who is going to present, not next, but right after, she actually had some code that actually does some of that, but it was in a more Pythonic way. And so I originally started with that, and my coworkers were like, there are so many command executions coming from this Python file. You need to cut it down. And so that's why I kind of revisited it and started to make things a little less noisy. So, yeah.
So have you had a look at, and this is probably a really large if Apple ever decide to update Python to 3 point whatever we're on, have you looked at how that would impact the tool, or would it just be a case of porting it?
So it'd probably be porting it. This week in the Objective-C, in the digital security training, I realized that I should probably learn Swift. So the next iteration of Venator will probably be in Swift because it'd probably be easier on me. It cause me less heartache. So yeah.
So everything you use there was in Kibana. So is the final output of everything in JSON?
The final output is just a JSON file.
So you could also load it into like Splunk.
Oh yeah, you could take that JSON file and put it in SIM solution of choice. Yeah, cool. Because most of the time I don't have, I have restrictions on what SIM I'm able to work with, especially with the client. And so that could be Splunk, that could be Kibana, that could be Graylog, it could be anything. So
And then is your computer name really Richie Rich's MacBook Pro?
no, I did that. Yep. Yeah, it's actually Casper because Spectre Ops is like stands for Ghost Operations, and so yeah.
I have a question.
Yep.
Have you found a good way to enumerate Safari extensions? Because Apple puts them in the keychain, you need special access to enumerate that.
Yeah, and so the Safari extensions module, it's a little like wonky, and so it's able to get some of the Safari extensions. Like I just added a bunch, and it got a good portion of it. But there was like one or two that it didn't account for at all because for reasons I have no clue. And so when they started to do some of the changes for Safari extensions, slowly but surely, like those extensions were like not visible in Venator anymore. So probably have to go back and revisit those. But yeah, that's a great point.
Yeah, it'd be nice if Apple had like an API.
Yep.
So
Yeah.
I'll pick on Apple. Any other questions?
Thanks for the presentation.
Yep.
Can I ask you, I'd rather have three small questions.
Yeah, sure.
The first one is, if you were to compare it to OS Query,
Mhm.
how much of OS Query do you cover, and what is it that you cover that OS Query doesn't?
So it pretty much covers a bunch of stuff that OS Query actually covers as well. Because OS Query in itself is a point-in-time tool, and so it's able to extract out a lot of interesting artifacts. And so the overlap between Venator's data and OS Query data is very, very similar. The difference between them is that OS Query has to be managed by a person, and this tool is just something that you could run using like maybe like Jamf across your environment, tell it to execute, or something like Ansible, and you're good to go. You don't necessarily need to manage that. So it covers it. The overlap is like almost 100%.
And the second part is, it's rather something I would love to see.
Mhm.
Maybe a switch that will allow to run extra stuff, like such as code science extract digital certificates.
Yeah, so in some of the modules, especially the launch agent modules, the applications, it'll tell you if the binary is signed, one, and it'll tell you if that binary is Apple signed or not. It'll say if it's Apple signed, if it's signed at all, and if it is signed, who was it actually like registered to, what developer or where did it come from? And so it has that information in there. But yeah, definitely it could definitely be more robust. So
And the last part is, do you ever encounter a case scenario when you need that for Linux?
for Linux, yeah. So actually, one of my colleagues at Spectre Ops is actually working on a Linux version, and so yeah, that'll be probably like by the end of this year we'll have a Linux version. So
Thank you very much.
yeah, thank you.